Finding square root by division method. When numbers are large, even the method of finding square root by prime factorization becomes lengthy and difficult. To overcome this problem, we use long division method. Now let us try to find out square root of 529 by this method. Now consider this number 529 and divide it in two parts. 529. Start from rightmost digit and form the groups of 2. Now as this number has odd number of digits, this one group of 2 digits is 29 and the other one contains only one digit, that is 5. Now we have to search for a perfect square which is closer and smaller to 5. Consider this first group, or it is also called as period, and let us find out a perfect square which is smaller and closer to 5. 5 is not a perfect square, then its preceding number is 4, which is a perfect square. So 4 is the required number, but 4 is square of 2, so we write 2 at 3 places. One is in quotient part and 2 times in divisor part. Here we add these numbers or add these digits. 2 plus 2 is 4. Now find out their product and subtract it from the first period. Here we get 1. Now take an entire period. So now we have 129 in our divisor part. Now we are going to find out one digit that will be written at 3 places, and product of this will be equal to smaller or exactly equal to 129. Now if we write 1, then 41 into 1 is 41, that is 2 smaller than 129. We can try for 2. This is 84, which is also smaller. Now let us try 43. 43 into 3 is 129. So we write here 3, 3, 3. This addition is 46 and this product is 129. Remainder is 0. Therefore the quotient part is square root of required number. So square root of 529 is equal to 23. Now let us find out square root of 4096. Method is same. Let us form groups of these digits. Start from rightmost digit, and now we have 2 periods. Now let us find out a perfect square which is smaller and closer to 40. 40 is not perfect square, 39 is not perfect square, 38 no, 37 is not a perfect square, but 36 is a perfect square. So we write 6 at 3 places. In divisor part we add these numbers, and in dividend part we find out product of these and that subtract from the first period. Here we have 4. Now let us write down the whole period, that is 96. So in dividend part now we have 496. Let us find a digit that will be written at 3 places such that product of these numbers or numbers so formed will be equal to 496. Let us try 4. If we write 4 here, the number over here is 124 and here is 4. 4 4s are 16, carry 1, 8 plus 1 9 and 4. So here we write 4 4 4 Addition is 128 and product of these numbers is 496, so remainder is 0. Square root of 4096 is 64. Let us find out square root of this number. 36864. Start from rightmost digit, divide the digits in pairs. If the digits are odd, the leftmost digit will be alone in that group or in that period. First period is 3. Find out a number which is smaller and perfect square, and which is also closer to 3. 3 is not perfect square, 2 is also not a perfect square, but 1 is a perfect square and it is 1 square. So we write 1 at 3 places. Here we add these digits to get 2, and the product of these numbers is subtracted from this period and we get 2. And now let us take 68 down. Now we have to find out a digit which will be written at 3 places, and the product of these two numbers will be closer, smaller or exactly same as 268. Now let us try to 5. So this number over here is 5 into 5 is 125. This is 2 smaller than this. So let us consider 27 into 7, and that is equal to 189. That is also smaller. So let us consider 29. 29 into 9 is 261. This is smaller and closer, so we write here 9 at 3 places. You are not allowed to write 10 because that is not a digit. Digit means a single number. This addition is 38 and this difference is 261. After subtraction we have 7, and let us consider this as our next period. Now there is a trick to find out the digit. Consider this and this. 3 2s are 6, which is smaller than 7. So we tried 382 into 2, that is 764. So the last digit is 2. We add these numbers here and let us subtract product of these numbers, that is 764, and answer is 0. Let us try to find out square root of a number which has a decimal point, 17.64. Now in these numbers we start making period from the place of decimal point. This is decimal point. Start from this digit, form the periods, again come to decimal point and form the period on left hand side. Now the remaining things are same. 17 is not a perfect square, but 16 is a perfect square, which is smaller, closer to 17, and it is square of 4. So we write 4 at 3 places. Addition of these two numbers is digits is 8 and their product is 16. Now put this decimal point in quotient part and take this period. Let us try. This is 8 and this is 16. 8 2s are 16. So let us try for 2. Yes, so we write 2 at 3 places. This is 84 and this is addition, and the product is 164. That gives a difference 0. Therefore square root of 17.64 is 4.2. Let us solve few more problems. 5776. Let us form group from rightmost digit. Find out a perfect square closer and smaller to 57. 7 square is 49. 8 square is 64. So the perfect square closer and smaller to 57 is 49. It is 7 square. So let us write down 7 at 3 places. Here addition, 7 into 7 is 49. Subtract it from 57, that is our first period. Difference is 8. Now let us take second or other period, that is 76. Now 14 6 are 84. So let us try for 6. 146 into 6. Yes. So here we write 6, 6, 6. This is 152 and product of these two numbers is 876 and the difference is 0. Let us find out square root of 7.29. Start making period from the place of a decimal point in both the directions. Perfect square closer and smaller to 7 is 4 and it is square of 2. 2 plus 2 is 4 and 2 into 2 is also 4. Put this decimal point in quotient part and take the next period. Now consider these two digits and this is 4. Now 4 8s are 32. So let us try for 8. This number is greater than 329. So now we will try for 7. 28 plus 4 is 32. Therefore we write here 7. Addition is 54 and difference multiplication is 329. Therefore square root of 7.29 is 2.7. Now there are one more type of questions, and the questions are what should be added or subtracted from a given number to obtain a perfect square. Sometimes some numbers are not perfect square, but if we subtract or add some number, then we get a perfect square. Like this, find a list number that must be subtracted from 5607 so as to get a perfect square. 5607. 5607 is not a perfect square, so at the last step our remainder will not be equal to 0 as this is not a perfect square. Let us start making periods from the rightmost digit. 56 is not a perfect square. Square closer and smaller to 56 is 49, that is 7 square. Let us write 7 at 3 places. We add that number, those digits in divisor part. We get 14. 7 into 7 is 49, and the difference is 7. Let us take next period. So our number is now 707. Let us consider this. 14 5s are 70. So let us try for 5. This is greater than 707, so we will write 4. This addition is 148, and this is 16 carry 1. 16 plus 1 17 carry 1 and 5. Here we get this difference as 1, and this is 13. So we should subtract 131. Now no more periods are there, so we have to stop here, and this is our remainder. Means this number is 131 extra than a perfect square. So we subtract. (131) from 5607 to get a perfect square. After subtracting 131 from 5607, here we have 6, 7 and 54, and square root of this 5476 is our quotient, and square root of this number is 74. So 74 should be subtracted from 5607 to get a perfect square. Now the similar question can be what should be added, which number should be added, must be added, so that we get a perfect square. Now here 1300, start making period from rightmost digit, and here we write 3, as 3 square is 9, and 9 is smaller and closer than 13. So 3 into 3 is 9, and 3 plus 3 is 6. Here we have 400. Now here we write 6, and 66 into 6 is 396. Now we have 4. Now this 1300 number is 4 more than a perfect square. So if we subtract 4, then we will get a perfect square, that is 1296. But our question is what must be added. So 36 square is 1296. Next natural number will be 37. And 37 square minus this 1300 is 1369 minus 1300. So we should add 69 to this number to get a perfect square. Find the greatest 4-digit number which is a perfect square. 4-digit number, greatest number which is a perfect square. Now 9999 is a 4-digit greatest number, but it is not a perfect square. Now we want a perfect square which has 4 digits. If we add 1, then you will get a 5-digit number. So adding 1 will not give us our answer. we have to subtract some number from 9999 to get a perfect square. Which number to subtract? That can be obtained by performing long division. "99" is not a perfect square, but a number smaller and closer to 99 is 81, that is 9 square. This is 18 and this multiplication is 81, so we get 18. Let us take next period. Now 18 nines are, let us try 18 nines are 162. So 189 into 9, carry 8. This number is smaller than 1800, so we write here 9. This is 198 and multiplication is 1701. 8, 9, 1, and no more periods are there, so this is our final answer, that we should subtract 198. Subtract 198 from 9999 to get a perfect square. So 9999 minus 198 gives you 1089, and square root of this number is our quotient, that is 99.